Okay, guys, today we're going to go over lecture 16. We're going to look at how to solve radical equations. We're going to look at complex numbers, imaginary I, and its conjugate of a complex number, which is a plus bi and a minus bi. So let's take a look at number 1, solving the radical equation of 4x plus 1 equals 1. Okay, so we have the square root of 4x plus 1 equals 1. Now the first step is to isolate the radical. Okay, right now the radical is isolated already. It's already by itself on the left side, so I don't have to do anything. I don't have to move it anywhere. The second step now is to perform inverse operations. Oops, sorry. A little bit misspelled. And solve for x. Okay, so now that the radical is isolated, I'm going to perform inverse operations and solve for x. Now the inverse operations are the inverse operation of addition is subtraction. The inverse operation of multiplication is division. The inverse operation of the square root is squaring something. The inverse operation of cube rooting something is raising something to a cube. So what I have to do now is square both sides in order to remove that radical. So what happens is I am just left with what's under the radical, which is my radicand. Now I'm going to continue performing inverse operations in order to solve for x. So my x equals 0. Okay, let's take a look at another example. We have the square root of 2x plus 8 equals square root of 4x minus 10. Okay, first step is I'm going to isolate the radical, and they're already isolated. They're both on separate sides. So now I'm going to just square both of them doing inverse operations. And I'm left with the radicand. Now I'm going to continue doing inverse operations and solve for x. Okay, now if I wanted to check if my answer was correct, I would go ahead and take my x value and plug it into wherever I see an x. And we have the same thing. Square root of 26 equals the square root of 26. So x is 9. Okay, pretty simple. You're just doing the same thing as you usually do when you're solving equations for a variable. You just continue to do inverse operations. Okay, so let's move on. Here we have C, we have the cube root of 2x plus 7 equals -1. Now we know that, just a side note, that an integer raised to an odd power is negative. Integer raised to an even power is positive. So when we ever raise an integer to an odd power, it's always going to be negative, and whenever we raise an integer to an even power, it's always going to be positive. So here we have the cube root of 2x plus 7 equals -1. The first step I need to do to solve for x is to isolate the radical. Right now it's already isolated, it's already by itself on one side. So now I can go ahead and start doing inverse operations to isolate the x. So the first thing I'm going to do is I'm going to cube both sides to remove that cube. So now I'm just left with my radicand. And -1 raised to a third power. Remember, any integer raised to an odd power is negative. So now we're going to continue doing inverse operations to solve for my x. X equals -4. Same thing, if I wanted to go ahead and check it, you would just substitute it back into the original equation. Okay, let's go ahead and continue. We have the square root of x plus 3 equals square root of x minus 5 plus 2 on the outside. Now, first step, isolate the square root. Now, whether I put the plus 2 on this side or the move it over here, it doesn't matter. So I'm just going to go ahead and start squaring it. So my second step, now, 1 second. All right, let's go ahead and continue. We're going to solve the square root of x plus 3 equal the square root of x minus 5 plus 2. Now, they're already isolated, so the second step would be to try to do the inverse operations to go ahead and remove the radicals. So I'm going to go ahead and square both sides. So now what happens here is it cancels out on this side, and on this side I technically have x, the square root of x minus 5 plus 2 times the square root of x minus 5 plus times 2. And then when I go like that, I get x minus 5, right? Radical x minus 5 times radical x minus 5, the radicals cancel out, and I'm left with x minus 5. Then I have radical x minus 5 times 2, that's 2 radical x minus 5. Then I have 2 times radical 5, that's 2x radical 5. Then I have 2 times 2, that's 4. Okay, now I'm going to go ahead and subtract my 4, combine a like term, so I see that I can combine these two over here. I can combine negative 5 and 4, so that's negative 1 plus 4 radical x minus 5. Then I'm going to go ahead and add 1 to both sides and get rid of that. I'm going to go ahead and subtract x on both sides. That gets rid of both. So I'm left with 4 equals 4 radical x minus 5. So what I did here is I subtracted the x on both sides. I got rid of it. Then I'm going to get rid of the 4 that's being multiplied here. So I'm going to divide it out. So that's 1 equals square root of x minus 5. Then I'm going to go ahead and square both sides. So I'm left with 1 equal x minus 5. Then I'm going to go ahead and add 5 on both sides. That leaves with x equals 6. So x equals 6. So this is step number 1, step number 2, step number 3, step number 4, step number 5, step number 6, step number 7. All right, let's move on. Okay, so now I'm going to go ahead and move on to number 2. Write as a multiple of I. So here we have a negative 16, square root of negative 16. Now I told you that when we usually have an even radical, an even index, and a negative radicand, we usually cannot simplify. But now we can simplify using imaginary numbers. Okay, so now just take a note that the square root of negative 1 is now I. We also know that negative 1 is I squared. So now if asked